Will we go over number 12 on page 535?
12 on 535, yes. 12, 535. Let's take a look. 535, number 12. Okay, very good. So we're given a function, and we are given a differential equation, and we are asked, does this function verify this equation? In other words, is it among the solutions? It may be the solution or among the solutions, so we have to check. Okay. As you see, the differential equation has the function in it, but also has the first and the second derivatives. So I have to find the first derivative first. E to the x is e to the x. Now, here I have to use the product rule, 3. First function prime is 1 times the second function plus x times the second function prime. I will distribute e to the x plus 3 e to the x plus 3x e to the x. And I see that I have 4 e to the x plus 3x e to the x. So now I will also have y prime. I also need to find y double prime, which is 4 e to the x plus 3. And I already know that when I differentiate 3x e to the x, I get this. But just to make sure that we are not making a mistake, I'm going to put parentheses, e to the x plus x e to the x, 4 e to the x plus 3 e to the x plus 3x e to the x, combined like terms, 7 e to the x plus 3x e to the x. So I have the second derivative, I have the first derivative, and I also have the function. All I have to do now is put them where they belong and see if I get 0. If I get 0, I'll go back and say yes. If I don't get 0, I'll go back and say no. So, second derivative, 7 e to the x plus 3x e to the x, minus 2 times the first derivative, minus 8 e to the x minus 6x e to the x, and plus the function, and see what we get. If we get 0, we'll say yes. If we don't get 0, we'll say no. So, 7 e to the x minus 8 e to the x plus 8 e to the x, these are gone. 3x to the x plus 3x to the x is 6x to the x, 6x e to the x minus gone, 0. So I go back and I say yes. Is this okay?
Yes, thank you.
Thank you. Are there other questions? Anything else you'd like to go back to? Any other from this or from the past? It doesn't matter.
We go over 6 on that same page.
Yes. Yes. You said 6. Good. 6. Okay, so we have y prime equals 4 over x minus 1 over x squared. And they're telling us that when x is 1, y is 5. I had a couple of students before we started, and I just wanted to see what I'm doing. I just didn't get the chance to open up the book in the background. Okay, that's what I was doing. And just have it ready for chapter 5. And 535. Okay. So let's take a look. We're asked to find the function whose derivative is given, and we also have an initial condition. And you know the initial condition is given to us in order to find what? Why is the initial condition given to us?
To find the constant.
Thank you so much. Thank you. Excellent. Yes. Good. Very good. So then all we have to do is just write that y equals 4 natural log of the absolute value of x plus 1 over x plus a constant c. So always remember, when I differentiate natural log, I get 1 over x. When I differentiate 1 over x, I get negative 1 over x squared. And we talked about this. Yes, you can change it into x to negative 2, but that's just doing more work. But it's up to you. I recommend remembering this correspondence. So now they're telling us that y is 5 when x is 1. So this is 0, and this is 1. And, oops, I didn't mean that, plus c. So therefore, c must be 4. So now we have the solution and the unique function whose derivative is this and passes through the point 1, 5. So then y equals 4 natural log of the absolute value of x plus 1 over x plus a constant that now was determined specifically to be 4. Good. Other questions? Is there anything else we need to go back to? Anyone? Other questions? Anything else? Okay, in that case, I'm going to, that's why I wanted the book to be open already. So basically, we looked at problems till up this point, till problem 15. So now I would like to look at this set. Find the general solution of each differential equation, and then check the solution by substituting it to the differential equation. That's fine. So these are all differential equations because, as you see, dc over dt is basically c prime. dv over dt is v prime, and so on and so forth. It's just that I think the notations are cumbersome, but we have to use them. They can represent anything, right? C, V, H, G, R, M, anything. So we have to get used to it. So let's choose an example. It's basically the same idea, just it looks different. Anyone, or I will choose?
Can we do 16?
16. Let's work on 16. So we have dm over dt is 0.05 m. Okay. So what we see here is a derivative of a function m with respect to t equals 0.05 m. The first step that we have to perform here is we have to multiply both sides by dt. Although this piece is the same thing with m prime, as we know, it's just a different notation. But we also learned in a previous chapter that this piece is the differential of m, and this piece is the differential of t. So, yes, together they represent a notation, but also they have separate meanings. So I'm going to multiply both sides by dt. Now let's see what happens next. dm equals 0.05 m times dt. The next step, I am going to divide both sides by m. Okay, so I have dm over m. equals 0.05 dt. What's all this? I'm going to explain in a minute. Now, if you remember, when we solve an equation, like let's say 2x plus 4 equals 0, we subtract 4 from both sides. So that's one option, one example. When we solve the square root of x plus 1 equals 4, we apply the same thing to both sides. We square both sides. In the past, we had to differentiate both sides of an equation. Well, in this case, I'm going to integrate both sides. The same idea. I do to the left exactly what I do to the right. I subtracted 4 from both sides. I squared both sides. I differentiated both sides. I'm integrating both sides. Okay, now, when I integrate the left-hand side, I get natural log of the absolute value of m. When I integrate the right-hand side, I get 0.05 t plus a constant c. Let's summarize what we just did and see if you have any questions. I was given that the derivative of m with respect to t equals 0.5 m. I multiplied both sides by dt, and I realize now that I have m on one side, but I also have m and t on the other. I'm trying to separate those. I want m alone on one side, and I want t alone on the other. So I had to divide both sides by m. Now, when I look on the left-hand side, after I put the integration symbol, I realize that when I integrate the m over m, I get natural log of the absolute value of m. Not connected to the left-hand side, when I integrate the right-hand side, I see that I have 0.0 t plus a constant c. I have to solve for m. And I have to remember from chapter 2 how to solve this equation for m. Remember, the base here is not written, but we know it's e. So how do I change this into an exponential notation? Anyone remembers how to change this into an exponential, not notation, equation? How do I change this log equation into an exponential equation? Anyone remembers? That is the most important conversion or relationship. Anyone remembers how to proceed? How do I change this log equation into an exponential equation? Anyone? So the absolute value of m equals e to this number. E to this is the absolute value of m. So e to 0.05 t plus c. Okay, is there anything I can do to simplify this? Yes. We can simplify this piece. How do I simplify it? Well, remember that a to the nth power multiplied by a to the mth power. Does anyone remember the rule? Copy the base, what happens to the exponents? Is anyone with me? Yes, Ariana, go ahead.
They be added together?
Yes, thank you very much. N plus m. But remember, this relationship goes back and forth. If I have a base raised to a sum, I can split the sum into a product of two pieces, e to this power times e to this power, because it's a sum. So I can go backwards. If I have e to a sum of two terms, I can go back and rewrite it as e to the first one times e to the second one. And I'm going to do just that. So the absolute value of m is e to 0.05t multiplied by e to c. But e to c is just a number. So I'm going to rewrite the whole thing as the absolute value of m. I'm going to change this into, you don't have to use the same c, you can use d, you can use c1, it doesn't matter, c1. E to 0.05t. Finally, because of the absolute value, m equals plus or minus c1 e to 0.05t. And by the way, what we just did, we separated the variables. We separated the variables. We're going to have plenty of examples, but let me just reiterate what we just did here. So this is a logarithmic equation. To change it and convert it, let me state the rule again. Log base a of x is y is equivalent to a raised to y equals x. So this is from chapter 2. It's from algebra. This is from a long time ago, but we reviewed it in chapter 2 when we talked about exponentials and log. So if I have a log equation, I can convert it into an exponential. If need be, I can convert the exponential back into a log. So this is what we have. So therefore, e to this power equals the absolute value of m. Then we went back to the exponential rule that states a to the nth times a to the mth, copy the base, add the exponents. But I can always go back. And this is what I have to do here in order to simplify. So it's e to this power times e to this power. But I don't care for this because it's just a number. I'm going to rename it as C1. I copy this. This is C1. This is the absolute value. I have to remove the absolute value by putting plus or minus in front. C1 e to whatever. So any questions on this, please? As I mentioned some time ago, differential equations, this portion is a little bit more intense, I would say. Any questions? Okay, so please feel free to choose the next problem. We can stay on these for a little while, and then we'll move on to the next step.
Miss Leah, can we do number 18?
Of course.
Thank you.
They're all the same. Okay. Just they're throwing notations at us. All the steps are identical. I have to multiply both sides by dt. I have to divide both sides by r. I have to integrate both sides. I have to write natural log of the absolute value of r, negative 0.35 t plus a constant c. I have to again write the absolute value of r is e raised to negative 0.35 t times e to c. I have to change this into a tiny number, e to negative 0.35 t. And finally, r equals plus or minus c1 negative 0.35 t. All steps are identical. Let's go back again. I multiply both sides by dt, and then I had to divide both sides by r to separate the variables. Everything with r on one side, everything with t on the other. When that is done, I just integrate. The left-hand side is natural log of the absolute value of r. The right-hand side, negative 0.35 t. Of course, plus a constant c because this is an indefinite integral. I use the property of changing a log equation into an exponential one. E raised to this equals the absolute value of r. We already learned that when the power is a sum, I can separate it into e to the first power times e to the second power. This is just a constant, nobody cares. I'm going to rename it as C1. Copy. Because of the absolute value, we have to put plus or minus in front. Is this okay? Is this okay?
Ms. Lee,
Yes, please.
can you go over one more time why you put the plus or minus?
Because of the absolute value. Very good question. Okay, let me refresh your memory. So the absolute value of x is either x when x is greater than or equal to 0, or is negative x when x is less than 0. We don't have any indication here. They're not telling us anything, unless they tell me that R means resistance of a light bulb, then I will not put plus or minus. But they didn't tell us anything about R. So when I solve the equation, let's say the absolute value of x equals 2, I have two options, x equals 2 or x equals negative 2. Because the absolute value of 2 is 2, but also the absolute value of negative 2 is 2. Is that better?
Yes, thank you.
Thank you. Anything else, other questions on the way?